This is a little video about how you curve the grades. We all know it when we have an exam or some tests where we run some scores. Let's say we have an exam where you can generate 70 points, and then we look at the scores we have, and then we look at the policy that we have about the average score. It doesn't really match up. So that's why we sometimes need to curve the grades. So here on this screen, you can see here on the side, I have a set of students that's taking an exam, and you can see the scores in the yellow column, where you can see the first one starts, from, well, the maximum points that you can get for this one, I've noted in the top, it's 76. And then you can see scores underneath that from each single student. So the first thing I normally do is that I add average, median, minimum, and maximum, so I can see the computation of each of the score calculations I have. And in this case, you can see that the average score in the exam was 55 points out of the 75. So that's the score. The maximum score was 67, and the minimum was 47. Now, in order to curve the grades, you have to, of course, have a target of what are you going to curve it against. In this case, for the school I'm working for here, we have a policy that we should, with this type of class, hit 3.3 or a B plus as the average grade. In this case, I'm looking at the grade policy, and as you can see here on the grade policy, this is the number of points that are associated with the different scores. In this case, a B plus starts with 86.5 and ends at 90. So what I do here, I set a target score of 88, so that's what I'm going to hit, and that's what you can see here on the column at the bottom, that I put in a target of 88%. So what we have to decide first is what type of grading do we want to have. And basically there are two different methods. There's one that's called the lift method, which is very normal when you have percentage scores, so 87% or 98%, things like that. And then you have a distribution method when you decide, for instance, you have 5, 6 grade brackets, how many people should be in each bracket. When we have percentage scores and point scores, it's typical to use the lifting system. So let's take a look at that first, how that would look. The first thing I do is then make a standard percentage calculation. And you can see here, the top one, it's calculated by taking the raw exam score for the student and dividing that by the maximum score. So that's the standard percentage that you find in Canvas, Blackboard, and other calculations. And in this case, you can see the point score here for all the students. Now, as you can see, I carry over the calculation for the mean, median, minimum, and maximum. And right now, we then have a mean score, an average score of 72.95. The target was 88, so you can see that we are 15% lower than the target. So definitely we need to curve the grades. So how do we do that? Well, the standard way to do it is to take your maximum score, and in this case, the maximum score in terms of percentage is 88.16. Now, you could also look at the maximum, which is 67, and move that up to 76. But I found it's much better to do it with the percentage scores. So that's what I'm doing here. So I'm going off that we have the top scoring student is 88.16, and the distance from that to 100 is the lift that we need to add to all the students. So let's take a look at what happens here. So you can again see the formula. We have the score of student A. That scores 63.16. We have a lift of 11.84%. And that's why we get the lifted score to 75%. And then I do that for all the students. And let's have a look at the calculation. Now we can see that the mean went up but it only went up to 84.79 with this standard lift score. So that is still about 3.2 percentage lower than we need to. So the standard curving doesn't work in this instance. We still need to compensate for that. So what do we do next? Well, what we could do is then, of course, look at the average grading. And in this case, we are 3.2% too low. So we can take that and add that to the lift. And that's what you can see up here. I've added that score to 11.84. So we now have a lift score of 15.05%. And then I basically do the same thing here in the column that's called grade score percentage. And so we lift it further with that extra score. And again, you can see now that the average is where we need it to be. It's at 88. But the problem here is that we have a maximum score of 103, and we only want that to be 100. So we're getting closer. We have the average where it needs to be, but we don't have the top where it needs to be. So the third step in the grade curve will then be to, if you want, compress the grading because we have too many at the top. So we need to get that under 100. But if we push under the top, in order to have the same distribution, we also have to push our little bottom part a little bit. So that's what I'm doing. We have a curve of grades. I push it from the top, push it from the bottom in order to hit the average grade. Now, in order to do so, the first thing we need to do is to sort it. So we have them in a ranked order, and in Excel, it's pretty simple. You just use the sort function and sort it after the total scores, and that's what I'm doing here. On this one, you can see that I've ranked ordered everything from the highest, so the largest score, to the smallest score, and then you can see here that we have 5 students that have over 100. So what I do here is then I take down the top score. In this case, it's 103.2 to 100. And then what I'm doing here is figuring out what should be the next one relative to the original score. So the original scores, it was 103.2, and then number 2 was 101.9. The distance there is a little more than 1, so I take half of that. So you can see I bring the second one down to 99.5. I look at the distance between number 2 and 3. Here we have a distance of 1.3. Take about that half of that distance off. So I give number 3 students 99. And you can see the 3, 4, and 5 scores the same, so they have to have the same score. Now let's look at student number 6. So student number 6 has 96.6. So what I do here is I round that up. And for the rest of them, they actually get the target lifted score. So you can see the top ones here are brought down under 100, and then pretty soon we actually hit the actual scores, the rounded scores. So that's what I put in here. The same thing happens at the bottom. And we need to lift it up. So the bottom student has 76.9. I lift that up to 78. So that's about a 1-point lift. And then you can see the 3 lowest one, as they have the same percentage score, they get the same corrected score to 78. Then the next one, there's a distance about a 1, so I lift that up to 79. So you can see the next ones, the next 4 ones here, they get the 79. And then we have a lift from 78.2 to 79.5. And I lift that up to 80. And then from there on, we actually hit the actual scores, the rounded scores. Now, when I do this little push from the bottom, and I've done this little push from the top, you can now see that we have the mean score, which is 88%. We also have a maximum of 100. So we now have curved the grades, and we've hit exactly where we need to hit it. Without messing with the internal logic, internal distribution of the students, which is pressed at a little bit from the top and a little bit from the bottom to hit the target. So that's kind of how you do it. Let's take a look at some of the formulas that are put into this one. I've had a question about that. There is a formula that you can use to follow the grade points, because sometimes there might be a difference in the grade points and the percentage scores because of the distribution. So in order to build up a grade point score, I use a VLOOKUP function. You can see the formula up in the top here. The VLOOKUP function is basically built on that you have a grading policy listed or a grading schemes listed, where you can see the percentages, the grade points, and the grades. And you will need this one to calculate the actual grade points and grades for the percentages that you're doing. But I like to follow that, so you can see at the bottom here that I also look at where are my grading averages in terms of grade points. We still need to hit 3.3, and I can follow that here. And in this case, you can see with the rounded one, we are at 3.27, and that is rounded 3.3. So we are right where we need to be. So that's it. Hopefully this was helpful, but that's a process of how you actually curve the grades. I also just wanted to show you the distribution scores. So here you can see the distribution of the raw scores, which is how they split out in the different bins. And at the bottom here, you can see that the distribution of the corrected scores. So you can see that the general distribution looks more or less the same with the same type of curving. So that's why this method, it messes as little as possible with the distribution of the scores when we are grading it. Let's take a look at the second model, so the distribution model. There are two major different methods, and the distribution method is also called the bell curve or similar method. So let's take a look at how you do that. So the first thing we have here is the raw exam scores from a test. Here you can see a list of the different scores I got from the test. And so the first thing we want to do is rank order them. It's very simple to do in Excel. You use data sort, and then you list it from the largest to the smallest. After you've done that, you insert a rank for each of them. So 1, 2, 3, and 4, and so forth. So you put in the rank number. And then once you've done the rank, you calculate a cumulative percentage. Basically, that means, how many are on this level or lower. The formula to insert, you can see here. I take the rank and divide by the total amount of observations, and in this case it is 50. And then the formula, you basically copy it all the way down in the cumulative percentage, so you have a percentage for each of the student scores. Now, once you've done that, then the discussion comes to what type of distribution are you going to use to split up the different grades by. There are a number of different ways to do it. So first of all, you have to decide how many brackets do you want. So how many grade steps do you want your grades to cover? There are a number of different ones to choose from. Here I've shown 8 and 7 and 5, just so you can see what they look like. The standard one, the standard bell curve one, normally starts with an 8 bracket, and the 8 brackets typically has a B to B minus as the average grade. Here you can see the distribution between 8 through to C minus grade. So you have 1% for A, 2% for A minus, 13 for B plus, for 34 for B and B minus, 13 for C plus, 2 for C, and 1 for C minus. Now, it is up to you to decide what type of distribution you want for the different grade brackets. But this is the standard normal distribution score. That's what it would look like, or a bell curve if you want. Now, once you've decided how big the brackets are going to be, then basically you have to identify how many points or more do you need to get to be in each of these brackets. So let's take one of them. Let's go to the B plus one. So here you can see that the number of students that gets a B plus or higher is 16%. So in order to get into the B plus, you have to be amongst the the first 16%. Now, if you go down in the cumulative percentage list, with your students, you can see that 16% equals 61 points, and then you put that score index in it. Let's look at A minus again. So here you have 3% cumulative share. If you go in on the cumulative percentage list in column Q, you can see that 3% is between 2 and 4, and that is between 67 and 66 points. We normally take the lower points. In this case, then the bracket for A minus would then be 66. And that's how it's done for the rest of the different grade brackets you can see here on the list. Now, once you have your score indexes, then you basically assign the different scores or different grades to the different scores. So you can see here I started with a 4 on the top, and the 4 we will award to students that have 67 or higher. We only have one student there. So the next one down has 66 points. 66 points, that's the bracket to get into the A minus one. So you see 3.7 for that person. Then the one after that has 65 points. 65 points is enough for a B plus. So for student number 3, all the way down to 61, so that is is that number 9 or something like that? Yeah, student number 9, they all get a B plus. And then let's go to student number 10. Student number 10 gets 60 points. 60 points is just under B plus, so that is a B. B is a B down to 55. So we take the 3 points from student number 10 and go down to when we see 55, and that is all the way down at student 26. So we input 3 down for that student, and that's what we do for the rest of them. In order to give them a letter grade, we could do it manually as well. I have put in a VLOOKUP formula that is used to identify that based on the grade point average. And in order to do so, you need to have a grading policy where you have your grade scores and the equivalent points and the different letter grades in it. So that's what you need to put up a VLOOKUP to do this automatically. But that's what I've done in my list here, so I don't have to put it in manually. Now, let's take a look at the average grade. For this method here, we can see it's 2.87, so that is between B and a B minus. However, if we have the target set at a B plus or a 3.3 average, then of course this model doesn't fly because then the grade is too low. There's also a model called the 7 bracket distribution model, which has, as it says, 7 different brackets, and you can see the brackets here, starting with 5%, 12, 20, 26, 20, 12, and 5. Now that is also a method that we can use. It then average that out on B, and it is done exactly like the 8 brackets distribution method I went through. So I will spare you that here. Here you can just see the different score indexes that we need to have when we assign the different grade points to the students, and that's what I've done here on the right side. If we look at the average here, you can see the average also calculates to 3 and a B. However, this is not a B plus, so this cannot be used for hitting B plus if that's what we want to do. The last one I have is a 5 bracket distribution model. Here you can see the 5 brackets goes from A to B minus, 7, 24%, 38, 24, and 7. With this grade distribution, we will hit B plus because that is the bell curve's average. We use the same method. Here you can see the different score indexes, and on the right side you can either see the different scores that aligns against these score indices. And at the bottom here you can see that we do have in fact a B plus as the average grade, which is where we need the grade to be. All right, so hopefully this little video was helpful. In case you need the spreadsheet that goes with this one, you're very welcome to reach out to me and send an email. You can see that on below here. And I will be happy to send you an example of the Excel sheet if you need it. That's it. Good luck with curving of your scores. If you have any questions, you can always add comments at the bottom here. See ya.